Hello girls, I hope you're staying safe at home. To continue with chemistry, today we are going to learn about alkenes. You already know, as I have previously discussed also, alkenes have two carbon atoms with a double bond. Okay, so alkenes are also known as olefins, which means oil forming. Why are they called oil forming? Because lower members of alkenes, they form oily products when they are treated with chlorine or bromine. And you know the general formula of alkene is CnH2n. Okay, so here we have the homologous series of alkenes. First we have ethene, common name is ethylene. So this is C2H4. There is a double bond. Okay, so between these two, you can see the double bond. That is why it is an alkene. Next one is propene. Common name is propylene. Structural formula, you can see the double bond between two carbon atoms. Molecular formula is C3H6. Next is butene, also known as butylene. So two carbon atoms having a double bond, C4H8 is the molecular formula. Pentylene or pentene has a double bond here, okay, and C5H10 is the molecular formula. So you have the condensed formula, and this is the structural formula. Children, please do not get mixed up between condensed formula and structural formula. Please see the difference clearly here. They are completely different, because I think in the last test that I conducted, many of you wrote the condensed formula for structural formula. So please see the difference clearly here. Now, you know, I already told you alkenes are unsaturated and they have a double bond. Now, alkenes are reactive, so they do not occur free in nature. Anything reactive, you know, does not occur free in nature. Lower alkenes occur in minute quantities, very less quantities in coal gas. They are produced on a large scale by the cracking of petroleum. Remember, cracking means heating at very high temperature. Okay, now isomers in alkene. Alkenes with 4 or more than 4 carbon atoms form isomers. For example, butene has 3 isomers. The first one is but1-ene. Next is but2-ene. Remember, this 1 and 2 indicates where the double bond is. Okay, and next one is 2-methyl propene. Okay, so there are two types of isomerism shown by alkenes. First one is chain isomerism, 1-butene, 2-methyl propene. Another one is position isomerism, 1-butene and 2-butene. That is the position where you will find the double bond. Okay, now we are going to talk about ethylene or ethene, which is the first member of the alkene series. It is found in natural gas. In small amounts, you find it as a plant hormone. Remember, we had discussed this in the chemical coordination in plants in biology too. And remember, this plant hormone is responsible for ripening of fruits. Now, structure of ethene. Each carbon atom of ethene is attached to 2 hydrogen atoms by a single covalent bond and to another carbon atom by a double covalent bond. So here you can see this is the structure of ethene. There is a double bond between these 2 carbon atom and single bond between the 4 hydrogen atoms. So as you can see, there are 4 single covalent bond between carbon and hydrogen. So 1, 2, 3 and 4. And there is 1 carbon-carbon double bond here. And all bond angles between hydrogen and hydrogen and carbon-carbon are of 120 degree. So you can see it here in this figure. Now, preparation of ethene or ethylene. is done by dehydration of ethyl alcohol. That means removing water from ethyl alcohol. So what are the reactants? Ethanol and concentrated sulfuric acid. So let us take a look at the apparatus. You can see a round bottom flask in which ethyl alcohol is added. Okay, ethyl alcohol, and then there is a thistle funnel here in which you have concentrated sulfuric acid. Okay, the ratio of ethyl alcohol and concentrated sulfuric acid is 1:2. That is, you take 1 part of ethyl alcohol and 2 parts of sulfuric acid, and then we heat it by means of a Bunsen burner. Here you can see, and there is a thermometer to check the temperature, because we have to heat it to 170 degree Celsius. After that, what happens? Ethylene starts evolving, and then you can see a bent tube here which is leading to sodium hydroxide, which removes impurities like carbon dioxide and sulfur dioxide, which is formed by the oxidation of the acid. And here you can see another bent tube leading to the beehive shelf, over which you have the gas jar inverted. Okay, and ethylene or ethene is collected by the downward displacement of water, and to the water a little bit of aluminum sulfate is added to avoid frotting. Frotting means lots of bubbles will be formed on the surface. Okay, now the reaction you can see here, ethanol reacts with sulfuric acid to form ethyl hydrogen sulfate, and excess of sulfuric acid at 170 degrees Celsius, because you know we are taking 1 is in the ratio 1:2, ethene is produced and sulfuric acid. So ethyl alcohol is dehydrated by sulfuric acid to form ethene or ethylene and water. Now, you already saw how the gas was collected. It was collected by the downward displacement of water. What is the reason? Because it is an inflammable gas. That means it will easily catch fire. And of course, it is being collected over water because it is insoluble in water. Okay, another method of preparation of ethene is by passing ethanol vapors through a tube containing alumina or aluminium oxide at 300 degree Celsius. So this is your equation for the preparation of ethene using aluminium oxide. Another method of preparation of ethene is by dehydrohalogenation. So here you can see chloroethane is treated with alcoholic hot and concentrated potassium hydroxide, and your product is ethene, potassium chloride and water. Similarly, bromoethane is treated with alcoholic hot and concentrated potassium hydroxide. Children, this is very important. Alcoholic hot and concentrated. That is the hint that you're going to get for certain equations, okay, like this one. So the product is again ethene, potassium bromide and water. Similarly, iodoethane, when you react it with alcoholic hot and concentrated potassium hydroxide, you get ethene, potassium iodide and water. Now moving on to the properties of alkenes, the physical properties. It is a colorless and inflammable gas with a faint sweetish smell. Its boiling point is minus 102 degrees Celsius and melting point is minus 169 degrees Celsius. It is sparingly soluble. Sparingly means very less. Okay, that is why it is collected by the downward displacement of water. But it is highly soluble in organic solvents like alcohol, ether and chloroform. Please remember the solvent in which it dissolves. Okay, and it produces an anesthetic effect upon inhalation. That means if you inhale it, you will become unconscious. Now moving on to the chemical properties. First, we have the addition reaction. addition of hydrogen. When hydrogen is added, it is known as hydrogenation. When ethene and hydrogen are passed over finely divided catalyst. So this is a catalytic reaction. Okay, so what are the catalysts used? Either platinum or palladium. At ordinary temperature, so when you use platinum and palladium, you use the ordinary temperature. And if you use nickel, then the temperature must be raised to 200 degree Celsius. So what happens? The two atoms of hydrogen molecule are added to the unsaturated molecule, which becomes a saturated one. That means ethene turns into ethane. Okay. So here equation is given for nickel as catalyst at 200 degrees Celsius, where ethene turns into ethane. Okay. Next is addition of halogens, which is known as halogenation. Okay. When it reacts with fluorine, it is very explosive. So the compound which is formed is not stable. So when chlorine, bromine and iodine are added to the double bond of ethene at room temperature, it forms saturated ethylene chloride, ethylene bromide and ethylene iodide. So here you can see ethene reacts with chlorine to form 1,2-dichloroethane. Similarly, with bromine, ethene forms 1,2-dibromoethane or ethylene bromide. Now, bromine solution in carbon tetrachloride shows an orange color. Remember the color, children. When added drop-wise, that means one drop at a time, the orange color of bromine disappears due to the formation of colorless ethylene bromide. Okay. Now, similarly, ethene reacts with iodine to form 1,2-diiodoethane or ethylene iodide. Remember that reaction with iodine is very, very slow, and ethylene iodide formed is unstable. Okay, it removes the iodine readily and regenerates the ethene. Okay, now next is addition of water, which is also known as hydration. A water molecule gets added to the alkenes in the presence of acids like sulfuric acid to form alcohols. Okay, so here you can see ethene with water forms ethyl alcohol. Next is addition of hydrochloric acid or hydrogen chloride when ethene gas is treated with hydrochloric acid, because this is always taken in aqueous form. Aqueous means it is an acid. Chloroethane is formed. So ethene with hydrochloric acid, ethyl chloride or chloroethane is formed. Remember, children, all these equations are very, very important. Okay. Now, if chloroethane, okay, that is this one, is treated with aqueous potassium hydroxide in water, ethanol is formed. So here you can see chloroethane with aqueous potassium hydroxide, ethanol is formed. Okay, and potassium chloride is also formed. Now next, moving on to polymerization. Okay, when polymerization in the photosynthesis chapter in biology, remember, when glucose molecules come together to form a bigger molecule of starch, then it is known as polymerization. So here also same thing, when two or more molecules of the same compound associate or come together to form a bigger molecule, the reaction is known as polymerization. So ethene polymerizes to form polyethene. So ethene, we don't know how many molecules of ethene, they come together at high temperature and high pressure, and they use catalysts. So polyethene is formed. That means the ethene molecules come together to form a bigger molecule of ethene, which is known as poly. Next is oxidation. So ethene is oxidized with alkaline potassium permanganate at room temperature. That is the normal temperature. So you can see in this reaction, in this equation, how ethene reacts with cold and alkaline potassium permanganate solution. This nascent oxygen comes from potassium permanganate, which is the oxidizing agent. So it is cold and alkaline. Okay, it results in uh, ethylene glycol. So ethylene glycol is 1,2-ethane diol. So alcohol, di means 2. Okay, which can also be written as ethan 1,2 diol. Okay, now the purple color, you know, the color of potassium permanganate is purple. It decolorizes, it becomes colorless because it gives away its oxygen to ethene. Now next we come to combustion of ethene. Combustion means burning. So ethene burns in air with a sooty flame. Sooty means lots of carbon is produced, producing a large amount of heat. But if the supply of air is in excess, if lots of air is given, it burns with a pale blue flame. Remember the color, children. What is the color of the flame of ethene? Pale blue if there is lots of air. Okay, and it produces, as usual, the products of combustion, carbon dioxide and water, and lots of heat. So this is your equation here. Now moving on to the uses of ethene. Ethene is used in making polythene. It is converted into ethanol, which is used as a starting material for making other products like cosmetics and toiletry preparations. And you know it is used in ripening of fruits, ethylene. It is used in making epoxyethane. Epoxyethane is used in the making of detergents, okay? And it is also used in producing oxyethylene flame, which is used for cutting and welding of metals. You have seen in garages and all, okay, the oxyethylene flame. It is also used in the manufacture of synthetic chemicals. So with this we come to the end of alkenes and even the end of organic chemistry. Why? Because you know the remaining three alkynes, alcohols and carboxylic acids have been deleted from your syllabus. So this is all in your organic chemistry syllabus. So when I'll take the test or what work you're supposed to do, I will let you know in the WhatsApp group. Till then, children, stay safe. God bless you.